Hello, this is Mr. Ford, and then we've got our gradient and rates of change unit now. So this is something that you would have learnt back in year 9 or maybe a bit sooner or later, but it's something that a lot of students really struggle with. And it is used in a lot of comparisons. It really tells us how we can compare data once it's been plotted. Okay, so let's have a little recap. And I can see some of you really thinking, oh, not again, but let's have a look. What is a gradient? So a gradient represents how quickly something is increasing or decreasing. So whenever I'm talking about gradients, what I'm really talking about is I'm always thinking in the x and y term as a graph, and I'm considering a point and looking to the right of my graph. How much or how fast is it increasing or decreasing? So how much is it going up? Now, the best thing is, because we're graphing this, we've got other ways that we're measuring and doing data, especially if we've got continuous or discrete data, we can actually use this to then represent something that's going to give us a numerical value. So we're going to get a gradient that has a number. So our gradient represents for every one across how many up we're going to go. So if I have a gradient of 3, that means that one value across the bottom means I'm going to go 3 up for whatever I'm measuring. So if I was thinking about the gradient of a hill, that means that for every 1 foot across or 1 foot up across, it's going to go 3 foot up, which is quite steep. Okay, now it's just something else entirely, but be careful because you'll notice when we're talking about hills and stuff outside, they don't use gradients because of how minor it is. They do something completely different. They do it in percentages. Okay, don't need to go through it, but that's something you can look up yourself. So everyone across how many up it goes, that's what gradient represents. Now, the reason that we do that is because we need to be able to measure it. So as you've got here, you've got your actual thing. We've got gradient, which you use the letter m. Okay, so we'll do this in our next thing when we're expressing data. You have your order y equals mx plus c. So your m is your gradient, where all we do is we do the change in height divided by the change in length. How do you remember this? Well, we think about it. Gradient is how much it's increasing or decreasing. So we want to find out how much it's going up or down. So that's what is the main measure. We're looking at height as our main measure. So it goes on the top and it's with respect to the length because it's on the bottom. So if I go 2 across, it should be twice as high. That's why we have to divide by the length. So another way of writing this, which you might have already seen, is change in y divided by change in x. That just reflects straightly, directly to a graph where y is height and x is the length across the bottom. And I've got some new symbols for you if you'd like to use shorthand, where this is a delta symbol, okay, which is just dy, dx. D means change in. As you can see from before, that delta just means change in y divided by change in x. Feel free to use them as you need or whatever you need, but the key point, it's the change going up divided by the change going across. Okay, so let's have a look. Oop, let me just fix this. These should all be fixed for you. It's just because I'm shifting things around. So here, we don't have any values. So that's still very important. So the curve below shows the volume of oxygen released as it varies with time of hydrogen peroxide at 298 Kelvin. Now, there is going to be questions, so this is a chemistry question. There's going to be questions that incorporate your knowledge of chemistry, but also we can just look at the comparisons on the rate of change, how fast it is increasing. Okay, so that's the first question here. Describe the rate of how volume released changes with respect to time. So what we can do is we can look at the start. The middle, and the end. So if we take the same value, this is why we use 1. Let's just say that's 1. If we take this value and we do that here, so if that's about that distance, it's about that distance, and about Oh, that's too long, but it has the same value. So the change in y. So the gradient, the rate of change is just the same as saying the gradient. The rate of this going up, how much it's changing, because this is changing. You can already see the fact that I've drawn the same x's, so we compare them against each other. So you can see that this value is much bigger than this value. Well, that's because this rate of change is much higher than this one, and at the end, it's not going up or down. So that means there is no rate of change. Okay, so what we would say here is we have a high rate of change at the start, at the beginning, which decreases in time because it's decreasing here until, okay, so at A it's actually decreased a little bit, so it decreases over time until there is no rate of change. Okay. That's it. Describe the rate of, so we're looking at the rate of change. We have lots of change, lots of height difference at the start, and it decreases until there is none. Okay, I'm going to get rid of this because we'll need this for the next question. So the next question here, explain what you need to do to find the rate of change of volume of oxygen released with respect to time at point A. Now, we want to find it at this point, right there. Okay, now if we go back to our dual-coded picture here, you'll notice something very important. When we do all of this, we actually do it with respect to y. It's a straight line. Okay, so what we need here is we need a straight line. So what I'm going to do is I'm going to draw a straight line. So what I would do with my ruler, I'd get my ruler and I'd slowly bring it in until it touches this point. I don't want it touching 2 points at once. I want it only touching one. Okay, that's known as a tangent. Now I've put 2 in here. There's an orange one, so let's zoom in. Okay, there's an orange one here, and the orange one, it's a bad line because it's touching at 2 points here and here. So let's get rid of it. This one is good because if you notice, it's a straight line. I'd use my ruler and it's only touching at this point. This is known as a tangent. So we draw a tangent at point A. Okay, so therefore we have our straight line, and then we find the change in x. We do what we did before. So we'd find a change in x and our change in y. Okay. So it's exactly what we're going to do, and that would give us our gradient. So our gradient, or our rate of change, because they are the same thing, would be our change in y divided by our change in x. How much it's gone up over how much it's gone across at this point. That's that rate of change at point A. Okay, now before we go on to getting you to do it, let's actually have a go. So here, you've got this next question. There's a student investigating lipase concentration and hydrolysis of lipids. Yeah. We've got great information there on for chemistry. But let's actually have a look. It might be biology, but that's not the point. Let's just look at the math and numeracy skills. Using the graph above, find the rate of change, there's your keyword, rate of change, at 5 minutes. So I've done it already, I've isolated. So first thing I've done is I've found 5 minutes. So first thing I've read, so from 0 to 2, that means that halfway is going to be 1, which means that's 3. And then what we really want is we want 5 minutes, which is here. So I'm going to read up. That is at 5 minutes. So I draw a tangent at that point, which is what you can see here. Draw a tangent at that point. Now that I have my tangent, I need to do my gradient. To find rate of change is just its gradient, how much it's changing, the rate at which it's changing. So I need to find the change in y. Now, it doesn't matter what you pick, but I like starting on these lines because I know that is 2 and I know that is 4. So let's go from here to here. So that's going to be across. Perfect lines. So I've got my change in y and I have my change in x. Well, my change in x is nice and easy. It is from 2 to 4, which is 2. What's my change in y? Okay, so now we have to read from our graph. So read across, that value is there, and then this one is there. Now we've got our reading of our scales again. So let's go back and have a look. It goes from 4 to 5. So we've got a value of 1. So this is a difference of 1. How many boxes are there? There's 10 boxes. So that means that, and again, you can guess and check, but you can use a bit of maths. What's 1 divided by 10? 0.1. So that means each of these is 0.1, and I always check 0.1, 0.2, 0.3, 0.4, 0.5, 6, 7, 8, 9, and 1. So that means that this is correct. So with that in mind, let's look at this one. So this is going to be 0.1. So that's going to be just above it. So let's say that's 5 point, so 0.1, say 1, 2. Okay, so it's just above that. What's important is that you're using your graph. Now this is what, when we do expressing data, this is why it's really important to actually have nice big graphs so you can read it to the most accurate level. And then what's it starting at? Let's have a look here. So we have read that across. It's halfway between these boxes. So let's do this. It's 0.1, 0.2, 0.3, 0.4, 0.5, which you would represent 6, 7. So this is 0.7, this is 0.8. So halfway between is going to be 5.75. Halfway between 0.7 and 0.8. So what's our change? We're going from this to this. So just by a little bit of maths, if I subtract them from each other, it's going down. Remember, this is going, our graphs, you can even see it. There's lines going down, so it's going down. So I'm going to put negative, okay, and it's going down 0.63. Okay, because the change in the y is this. Let's find it out. Let's finish this off. So our gradient, our rate of change is negative 0.63. Our y, because we're doing height first, divided by 2, which is negative 0.315, okay, pH per minute. And I can't write minute. That is it. Okay. And I'm just using the scales and the labels to then do that. Okay. Last thing I want you to do is I'd like you to go through and actually do the 2 questions that follow. Okay, there's another one on business and there's another science style question for you to do.